Every night, your brain creates an alternate reality. You see people who aren't there, you experience danger without it, you feel emotions without consequences. And yet, scientists still don't fully agree on why we dream. For something we spent nearly 6 years of our life doing, the purpose of dreaming remains one of neuroscience's most fascinating debates. So, tonight, let's explore the science, not the symbolism behind why we dream. What actually happens when we dream? Most vivid dreaming happens during REM sleep, rapid eye movement sleep. During REM, your brain activity becomes almost as high as when you are awake. The visual cortex is highly active, the amygdala, the brain's emotional center, becomes very active. But the prefrontal cortex, responsible for logic and rational thinking, becomes less active. That's why dreams feel emotional but not logical. Your brain is active but not fully rational. This neurological imbalance is central to the debate. The major theories and why they disagree. There isn't one dream theory, there are competing explanations. Let's look at the major ones. The activation synthesis theory, proposed in 1977 by Harvard psychiatrists Alan Hobson and Robert McCarley. This theory suggests dreams are essentially the brain trying to make sense of random neural firing during REM sleep. The brain system activates, signals are sent randomly. The cortex tries to synthesize meaning from that chaos. In simple terms, dreams may not have meaning. They may just be the brain interpreting noise. This theory was revolutionary because it removed mysticism from dreaming. But critics argue it's too reductionist because dreams often follow emotional patterns, not pure randomness. The memory consolidation theory. Another major theory suggests dreams help consolidate memory. During sleep, especially REM and deep sleep, the hippocampus replays experiences from the day. Important memories are strengthened. Irrelevant details are pruned. Studies show that people deprived of REM sleep struggle with memory retention. So, dreaming may be part of the brain's nightly data processing. But here's the problem: memory consolidation also happens in non REM sleep. So, dreaming itself may not be necessary for this process. The threat simulation theory, proposed by Finnish neuroscientist Antti Revonnuso. This theory suggests dreams evolved as a survival mechanism. Dreams simulate threats so we can rehearse a response in a safe environment. This explains why many dreams involve danger. Negative emotions are common, nightmares are more vivid than pleasant dreams. From an evolutionary perspective, rehearsing danger could improve real world survival. But critics ask, if dreams are meant for survival rehearsal, why are so many dreams bizarre and unrealistic? The emotional regulation theory. This theory suggests dreams help us process emotions. During REM sleep, the amygdala is highly active. Stress hormones like norepinephrine drop significantly. The chemical environment allows brain to revisit emotional events without the full stress response. Some researchers call this overnight therapy. There is evidence that REM sleep reduces emotional reactivity the next day. But again, not all dreams clearly process emotional events. So this may be part of the story, not the full story. Why there is no single answer? The reason scientists disagree is simple. Dreaming likely serves multiple functions. It may consolidate memory, regulate emotions, simulate threats, maintain neural networks, or simply emerge from brain activation patterns. The brain is not single purpose, it is layered. Dreaming may be a byproduct of REM sleep that evolution later found useful, or it may be a necessary function with randomness layered on top. We don't know yet. What makes dreaming so fascinating is this: while dreaming, your brain generates an entire reality without external input. That means your brain is capable of building a full world with physics, characters, narrative, and emotion internally. Dreaming may not just tell us why we sleep, it may tell us how consciousness itself works. For centuries, dreams were interpreted as prophecy. They were seen as symbols. Now they are studied as neural processes. But even with brain scans and sleep labs, the question remains open: why do we dream? The honest answer is we're still debating it. And that might be the most interesting part. Because every night while your body rests, your brain is running experiments we are only beginning to understand.